Dear students, welcome to my classroom. In previous class, we solved the exercise 11.2 based on trigonometric ratios of specific angles 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. In this class, we are going to study about trigonometric ratios of complementary angles. Students, you know the meaning of complementary angles. Again, I am repeating, two angles are said to be complementary if their sum is 90 degrees. Two angles are said to be complementary angles if their sum is 90 degrees. That is, for example, 30 degrees and 60 degrees are complementary angles of each other. Also, 10 degrees, 80 degrees. And the complementary angle of 20 degrees is 70 degrees, as well as the complementary angle of 70 degrees is 20 degrees. And the complementary angle of 45 degrees is itself. Okay. Now, let us take a triangle ABC in which angle B is equal to 90 degrees. As the sum of angles in a triangle is 180 degrees, and apart from this right angle, we have two more angles, and they are angle A, angle C. And the sum of these two angles, angle A and angle C, is also 90. Assume that angle A is theta. Then angle C is 90 degrees minus angle A. That is 90 degrees minus theta. If the figure is like this, angle A is theta, angle C is 90 degrees minus theta. So here the theta and 90 minus theta are complementary angles of each other. That is, angle A and angle C are complementary angles of each other. Now, find the trigonometric ratios with respect to triangle, with respect to angle A, that is angle theta. So from triangle ABC, sine theta is equal to opposite side by adjacent, that is BC by AC. Now cos theta is equal to AB by AC, because adjacent by hypotenuse. Tan theta is equal to opposite by adjacent, which is BC by AB. Cosec theta is equal to inverse of sin theta, that is AC by BC. Sec theta is equal to AC by AB. Cot theta is equal to AB by BC. Students, now find the trigonometric ratios with respect to angle C, that is with respect to angle 90 minus theta. By finding the trigonometric ratios with respect to angle 90 minus theta, we can observe that sine 90 degrees minus theta, sine 90 degrees minus theta is equal to opposite by hypotenuse, opposite to angle C by hypotenuse, that is AB by AC. But here AB by AC is equal to cos theta. Okay. And take cos 90 degrees minus theta. Cos 90 degrees minus theta is equal to adjacent by hypotenuse, BC by AC. But here BC by AC is equal to sin theta. Similarly, tan 90 degrees minus theta is equal to AB by BC, and that is equal to cot theta. Similarly, we can observe that cosec 90 degrees minus theta is equal to AC by AB, which is equal to sec theta. Sec 90 degrees minus theta is equal to AC by BC, which is equal to cosec theta. And cot 90 degrees minus theta is equal to BC by AB, which is equal to tan theta. So students, from this, we can conclude that sine of 90 degrees minus theta is equal to cos theta, and cos of 90 degrees minus theta is equal to sine theta. Tan of 90 degrees minus theta is equal to cot theta, and cot of 90 degrees, cosec of 90 degrees minus theta is equal to sec theta. Sec of 90 degrees minus theta is equal to cosec theta. Cot of 90 degrees minus theta is equal to tan theta. Here we can observe one more point here. Sine of 90 degrees minus theta is cosine. That is complementary angle of 90. Sine is cos, that is cosine, and complementary of cosine is sine. Complementary of sine is cosine, complementary of cosine is sine. Similarly, complementary of tan is cotan, and complementary of cotan is tan. Complementary of cosec is sec, and complementary of sec is cosec. Okay. So let us solve the problems based on this concept, complementary angles, in exercise 11.3. So first one, evaluate tan 36 degrees by cot 54 degrees. So here the given one is tan 36 degrees by cot 54 degrees. We don't know the value of tan 36 degrees and cot 54 degrees. But we can observe that these two angles are complementary here, because sum of 36 degrees and 54 degrees is 90. So 36 degrees and 54 degrees are complementary. So in any of these two angles, write one angle as the difference of 90 degrees. That is, we have to write either 36 degrees is equal to 90 degrees minus 54 degrees, or 54 degrees equal to 90 degrees minus 36 degrees. We have to change any one value into the difference of 90 degrees. So let us change the value in numerator. That is, write tan 36 degrees as tan 90 degrees minus 54 degrees. Because we know by calculation we get again 90 degrees minus 54 degrees as 36 degrees. Okay. But we have tan of 90 degrees minus theta is equal to cotan theta, that is cot theta. Okay, complementary of tan is cot. So that's why we get here tan of 90 degrees minus 54 degrees as cot 54 degrees. Because we have the formula tan of 90 degrees minus theta is equal to cot theta. That's why tan of 90 degrees minus 54 degrees is equal to cot 54 degrees. Here the values in both numerator and denominator are equal. So by cancelling we get 1. So the answer is tan 36 degrees by cot 54 degrees is equal to 1. Okay. Let's solve another one. Cos 12 degrees minus sine 78 degrees. So here also given problem is cos 12 degrees minus sine 78. Here also we don't know the values of cos 12 and sine 78. But we can observe that 12 degrees and 78 degrees are complementary. Because 78 plus 12 is equal to 90. So here also we have to change one angle as the sum of 90 degrees. So here I am changing 12 degrees like 90 degrees minus 78 degrees. Now we have cos 90 degrees minus 78 degrees. And it is of the form cos 90 minus theta, which is equal to sin theta. So we can write it as sin 78 degrees minus sine 78 degrees. Because here cos 90 minus theta is equal to sine theta. So sine 78 minus sine 78 is equal to 0. So cos 12 degrees minus sine 78 degrees is equal to 0. Okay. Let's take another one. Cosec 31 degrees minus sec 59 degrees. Here also 31 and 59 are complementary. So write 31 degrees as 90 minus 59. Now we have cosec 90 minus theta is equal to sec theta. So sec 59 minus sec 59, which is equal to 0. Okay. Here cosec 90 minus theta is equal to sec theta. So answer is 0. And the next one is sine 15 degrees into sec 75 degrees. So take the question sine 15 degrees into sec 75 degrees. Here also 15 degrees and 75 degrees are complementary angles of each other. Now write 15 degrees as 90 minus 75. Now it is of the form sine 90 minus theta. So it is equal to cos theta, that is cos 75 degrees and into sec 75 degrees. Students, we know that multiplicative inverse of cos theta is sec theta. Okay. Multiplicative inverse of cos theta is sec theta. That's why cos theta is equal to 1 by sec theta or sec theta is equal to 1 by cos theta. So change any one of these two ratios into the form of another one. That is cos change sec 75 as 1 by cos 75 because sec theta is the multiplicative inverse of cos theta. Since sec theta is equal to 1 by cos theta. Now cancelling cos 75 in these two, we get 1. So the answer is 1. Okay. Take another one. Tan 26 degrees into tan 64 degrees. Once again, we have complementary angles here. So change tan 26 degrees as tan 90 degrees minus 64 degrees, which is of the form tan 90 degrees minus theta and is equal to cot theta, that is cot 64. Here the reason is tan 90 degrees minus theta is equal to cot theta. And we know that tan and cot are multiplicative inverses of each other. That is cot theta is equal to 1 by tan theta and tan theta is equal to 1 by cot theta. So write tan 64 degrees as 1 by cot 64 degrees. And now by cancelling, we get 1. So the answer is 1. And let us solve the second problem. Show that tan 48 degrees, tan 16 degrees, tan 42 degrees into tan 74 degrees is equal to 1. So we have to show that the product of these four trigonometric ratios is equal to 1. So take LHS of given equation. The LHS is tan 48 into tan 16 into tan 42 into tan 74. We don't know the values of these trigonometric ratios, these specific angles. But we can observe here that 48 and 42 are complementary. 16 and 74 are complementary because their sum is 90 degrees. Now, in these two, that is in tan 48 and tan 42, change any one ratio into its complementary ratio. And similarly, in tan 16 and tan 74, change one trigonometric ratio into its complementary ratio. So I'm changing here 48 degrees as 90 minus 42 and 16 degrees as 90 minus 74 degrees, like this. Now we have tan 90 degrees minus theta is equal to cot theta. So here I am getting cot 42 degrees, cot 74 degrees, and the remaining is same, tan 42 degrees, tan 74 degrees. The reason is tan of 90 minus theta is equal to cot theta. And we know that cot is the multiplicative notes of tan. So right here, tan 42 as 1 by cot 42 and tan 74 as 1 by cot 74. Because tan theta is equal to 1 by cot theta. And now by cancelling cot 42s and cot 74s, we remains with 1, which is equal to RHS. That is LHS is equal to RHS, and the given equation is right. Okay. And the second one is cos 36 degrees, cos 54 degrees, minus sine 30 degrees, 36 degrees, sine 54 degrees. Now, here also take LHS. Cos 36 degrees, cos 54 degrees, minus sine 36 degrees, sine 54 degrees. Change these two values into its complementary angles. That is cos 90 minus 54 and cos 90 minus 36. And these are of the form cos 90 degrees minus theta, which is equal to sine theta. So we can write sine 54, sine 36. Again, here we have sine 36, sine 54. Both are same, so that their difference is 0. Okay, which is equal to RHS. Therefore, LHS is equal to RHS. Now let us solve third problem. If tan 2a is equal to cot of a minus 18 degrees, where 2a is an acute angle, find the value of a. This is the question. So it is given that tan 2a is equal to cot of a minus 18 degrees. We know that tan is complementary angle of cot. So change any one of these two trigonometric ratios into their complementary angles. That is, we can write tan 2a is equal to cot of 90 degrees minus 2a. Because we know that tan of cot of 90 minus theta is equal to tan theta. Now, here the ratios of 90 degrees minus 2a and a minus 18 are equal. So we can equate the angles. That is 90 degrees minus 2a is equal to a minus 18 degrees. And now by simplification, we get 3a is equal to 108 degrees and a is equal to 108 degrees by 3, that is 36 degrees. Therefore, angle A is equal to 36 degrees. The value of A is 36 degrees. Let's take another one. The fourth one is, if tan A is equal to cot B, where A and B are acute angles, prove that A plus B is equal to 90 degrees. So here the given one is tan A is equal to cot B. So change tan A as cot 90 degrees minus A, because cot 90 minus theta is equal to tan theta. Here also cot of 90 degrees minus A is equal to cot of B. So by equalizing the angles, we get 90 degrees minus A is equal to B. That is, by transforming A to right side, 90 degrees is equal to A plus B. So here we got our required equation, A plus B is equal to 90 degrees. And the next one is, if A, comma B and C are interior angles of a triangle ABC, then show that tan of A plus B by 2 is equal to cot C by 2. So, students, here A, comma B and C are angles of triangle ABC. So, as A, B and C are angles of a triangle, we have angle A plus angle B plus angle C is equal to 180 degrees. From this, we can write A plus B is equal to 180 degrees minus C. And dividing by 2, we get A plus B whole by 2 is equal to 180 degrees minus C whole by 2. And from this, we can write A plus B by 2 is equal to 180 by 2, that is 90 degrees minus C by 2. And now taking the ratio tan on both sides, because here we have tan in our required equation. So take tan on both sides. We get tan of A plus B by 2 is equal to tan of 90 degrees minus C by 2. And we know that tan of 90 degrees minus theta is equal to cot theta. So here we can write cot C by 2. Here is the result. So therefore, we get tan of A plus B by 2 is equal to cot C by 2. Hence proved. And the next problem is, express sine 75 degrees plus cos 65 degrees in terms of trigonometric ratios of angles between 0 degrees and 45 degrees. So take the given one, sine 75 degrees plus cos 65 degrees. If we have to change the values into the angles between 0 degrees and 45 degrees. So we can write it as 90 degrees minus 15 degrees, and this one as 90 degrees minus 25 degrees, like this. Now we have sine 90 degrees minus theta is equal to cos theta, as well as cos 90 degrees minus theta is equal to sin theta. So here we get sine cos 15 degrees plus sine 25 degrees. And the reason is this one. So in this way, we can change this trigonometric ratio of angles between 0 degrees and 45 degrees. Okay, students, that's all for today. And in next class, we are going to find the trigonometric identities. Okay, so see you in next class. Bye.